Hi everybody, my name is Julie Beaver and I teach college algebra in pre-calculus at Zimmerman High School up in Zimmerman, Minnesota. And for our college algebra, we use the Blitzer Algebra and Trigonometry 5E book. And then for pre-calc, we use Pre-Calculus Graphical Numerical Algebraic 8th edition. And so I went through my college algebra text, and that's what I'll be talking about, but maybe some of you get to use the same pre-calc text as well. So as I'm looking through the prerequisites, all sorts of amazing algebra in here that we've been doing this week. In my course, we cover the prerequisites pretty quickly. We spend a month on it just to make sure that they're good and ready to go with all of the algebra left over. So algebraic expressions, mathematical models, real numbers. One of the things that we spent time looking at this week was just the whole number. All natural numbers are whole numbers, and looking at the notation that we use for that, which I never thought was important until these last few months when I took combinatorics and now taking this course, needing to know what the notation is for real numbers. Well, I always knew that, but complex numbers and integers and all sorts of good stuff. I feel like I've been able to do so much more in depth with my college algebra and pre-calculus kids because of the coursework that I've been doing here. So exponent, scientific notation, that's good. Not necessarily hugely algebraic until you hit P4, which is polynomials, and then P5, factoring polynomials. My word, I could factor polynomials all day long. Rational expressions, putting those polynomials into fraction form, which is pretty scary for my students, but I found that has also made me a better teacher to the younger kids because I understand now, here's why we have to know how to actually divide a fraction where you keep and you multiply the reciprocal, why that's important, and why tricks are bad and they kind of are a lie after maybe 9th grade, that now you can't just do a trampoline to multiply fractions. You actually have to understand the concept of keep the first one, multiply the reciprocal. Graphs and graphing utilities, always important. Linear equations and rational equations, ooh, gotta love those. And quadratic, awesome, super fun. Other types of equations, linear inequalities and absolute value inequalities. I love doing absolute value inequalities, but I have found that they're pretty challenging for students. So being able to do a two-dimensional graph and then a one-dimensional graph is super helpful for the kids, I found. Then chapters 2 and 3, basics of functions. I love putting the linear functions together, the slope transformation. One of the things that I like about college algebra and pre-calculus is we start working with all sorts of functions, and the students start really understanding that if you have x plus or minus something, they start seeing that it's not about memorizing what that does, but that every function is moved the same thing. If it says x plus 2, they're starting to realize, oh, no matter what the function is, that moves it left 2. And figuring out what is a vertical movement and what is a horizontal movement. I find that this is the course where that really solidifies in their brain, which is always exciting. Inverse functions, distance and midpoint formulas, which are always good, and then go to circles. Quadratic functions in chapter 3, polynomial functions and their graphs, dividing polynomials. Oh my gosh, when we get to remainder and factor theorems, finding zeros and synthetic division, I do it. I love those units. I do their home fun for fun. Rational functions and their graphs, polynomial and rational inequalities, and then the modeling piece, because the math is no good if we can't actually model real world situations with it. I mean, it's beautiful and it's fun for us, but maybe not for them until we can put it into a real world context for them. Then we hop over to chapter 8, systems of equations and inequalities, and we do a lot of work with matrices in and around here, which I think is so important that students kind of see, here is my set of equations and how I can use that information to answer good questions. But I love when they can take those equations, put them into a matrix, and figure out how this is so much faster and how that would work in a computer program. Then 9, so here's where the matrices comes in from chapter 8. You start with the systems of equations, then go to the matrices. And determinants, Cramer's rule. I thought it was really interesting taking combinatorics this summer, as I found that the determinants are really helpful. So that gives me more excitement around teaching the students that and saying, you don't ever use this. Now I found out, yeah, you actually do. So that's always fun. And last but not least, oh goodness, chapter 11 down on the bottom. Sequences, induction, probability, all the good things that we did in combinatorics with your sequences, arithmetic and geometric, mathematical induction, starting to prove fun things, binomial theorem, counting principles, permutations, probability, all those cool ways that we can count things. So those are the places that algebra pops up in my college algebra course. There's, some trigonometry involved as well, but we're just looking at algebra today. So there it is, my Blitzer algebra and trigonometry 5E.